I'm really proud to be the person to announce, once again, Ariya is giving us a great talk. He had an awesome talk last night, and he's going to talk this morning about next generation JavaScript language tooling. So let's give a big hand for Ariya.
Good morning. Gosh, why do I have a talk right after Dave's? That's going to be awesome. I'll try my best. My name is Ariya. I work for a security startup called Shape Security. But for the next 30 minutes, the only security-related things that I want you to care about is job security. This Neanderthal JavaScript programmer, he doesn't exist anymore. And if you don't believe me, just look to your left and look to your right. He didn't adopt the new way of modern web development. He didn't care about responsive web design. He wasn't into ECMAScript 6. So one day he woke up and told himself that, hey, probably this is not for me anymore. So he decided to retire, pursue his personal interests, spend more time with friends and family and that kind of thing. So fortunately for us, we have tons of tools out there that allows us not to end up like that poor fellow. In this presentation, you'll see a bunch of tools that can be categorized into these three buckets: static code analysis, syntax transformation, and dynamic code analysis. It's really difficult to explain each individual tools just in the time that we have. So most of the time, I'm just going to fly through it. All the tools are out there. You can do whatever you want. The slide deck is already online. It's also sprinkled with tons of links, so you can follow it up later. Now, the basic principle of modern JavaScript tools is just three things: do one thing, work together, and have a universal interface between those tools. Does anyone know what it is? This is not Agile Manifesto. This is the philosophy of Unix. And if you talk about combining blocks of tools, the first thing that we need to do is to be able to understand the structure of your code. So if you write var answer equals 42, being able to extract that information in the form of syntax tree will be extremely important. That's the first step. And after that, you can combine this parser with a bunch of other tools. For example, the parser consumes my code, it generates a syntax tree, I can do manipulation to my syntax tree, and you have another block that acts as a code generator, and it generates another code. So this is the basic principle of minifier, obfuscator, etc. So by combining all these blocks, you can build something that fits your development workflow. So gone are the day where you have one giant monolithic code base that does everything under the planet. If you look at this block, if you switch or you substitute code generator with a simple interpreter, you can have a very powerful JavaScript execution visualization. This is easier to explain, to demonstrate than to be explained. Look, do I have that? Oh, yeah. So whatever code that you type there is going to execute it in slow motion. This is called Meta JavaScript Interpreter. You can even see the change in all variables and what is being executed in the expression stack. I don't think we have time to watch this all day long, but you get the idea. Now let's dive in directly. First is static analysis. Based on the syntax tree that we have, we can build various tools that detect a particular code pattern. This is the most obvious one. How many of you here forgot to remove console in production? Or any other debugging statement? Everyone falls into this trap once in a while. If you have a console.log expression in your code, the syntax tree will look like on the left side there, the tree. There will be a member expression that calls an object console with a property log. So if you want to detect that, you parse your code, walk through the syntax tree, and try to figure out if there's a pattern that matches that kind of subtree. And if there's one, then you complain or shout or give warning to the user. Another thing is Boolean traps. I'm sure from yesterday's keynote you can understand my crusade against Boolean traps. In this example, reload x, y, false, I want to detect the existence of such Boolean literals. as the few last function arguments in the functions. So if you parse that and produce the syntax tree, you're going to see the tree like on the left side. All I need to do is walk through my syntax tree and detect if there's a call expression that has a Boolean literals in the arguments. Before I forgot, you can use an online tool that I built to visualize your syntax tree. So whatever you type here, which is valid JavaScript code, you're going to see the syntax tree JSON formatted on the left side, and you can see the visual tree version of that particular code. Another annoying thing about JavaScript is because you can abuse it. You can use the question mark colon operator, which produces the ternary conditionals, and nest it like crazy. In this example, it's not so bad because the code is very much aligned and it's very simple conditions. But if you look at the syntax tree, you're going to see a conditional expression nested inside a conditional expression, nested inside another conditional expression. These three code pattern detections is an example of a custom linting. So yes, you can rely on JSLint or JSHint to do a code quality analysis on your code, but in many cases, your project has certain requirements. For example, if the file is called foo.js, maybe the class name or the module should be called mycompany.foo. Or identifier needs to use camel case, or it cannot contain underscore, etc. All this kind of project-specific requirements or code guidelines, they won't be able, that you cannot use existing off-the-shelf tools to detect that because that's specific to your projects. And therefore, it's very important to capture that kind of project-specific guidelines and turn it into tools. If someone creates a patch and it violates some of the tools, and you catch that during your review, and you do it multiple times, at one point, just automate that. It should be a job for a machine, not for you. Another thing that is going to be really big is understanding the complexity of your code. In layman terms, cyclomatic complexity correlates to the branches inside your program. For these simple one-line examples, if true, foo, else bar, I have one statement that branch into two because it's just a normal if statement. Via some complicated computation, it has 6 edges, 6 nodes, 1 exit. The cyclomatic complexity of this line is 2. So the code that analyzes this already exists. It's called JS complexity. There is an online version, and there's a command line modules for Node. It does control flow analysis of your code, and then computes the cyclomatic complexity, both aggregate for the entire file or on a function basis. And if you're crazy, you can implement a continuous monitoring of complexity, put it in your continuous integration system, Travis CI, Jenkins, etc. In this example, I inject a simple logic to detect the most complex function in my file, in my code, and then show it as the outcome of my build system. That way, I want to make sure that I will not introduce a function that is way more complex than it should be. This is also important for refactoring. If you want to refactor something, then maybe start from something that is very complex as opposed to some plain vanilla function. Or if someone improves functions and then suddenly the complexity doubles, then maybe he should refactor it, split it into 2 functions, do crazy things in different places, etc. This is basically the moment where you can say, I don't want complex code to ever enter my my code repository. Can anyone tell how many things are wrong with this poster? So that's about static analysis. And if you have managers who likes to see charts and colors and etc., you can apparently you can also visualize complexity. So you can use tools called Plato that generate charts of your code. So it does again use just complexity to pull the cyclomatic complexity of each function and aggregate and a bunch of other metrics. It's very cool. Check it out. Now let's move on to syntax transformation. There are 2 different ways to transform JavaScript code. The most common way is something that I call regenerative. So the parser takes your code, produces syntax tree, and feed it to code generators. Let me just demonstrate that. So this is a source rewriter that takes your code and then reformat it according to the indentation and the literal quotes that you want to specify. So if I click this, it just takes my code and generate the new code that conforms to that coding style. In that regenerative approach, the original code is completely thrown away. There's also another mode which is called non-destructive. So what it does is it still modifies your original source code. It just tries to pay attention to the one that it cares about. The most obvious example, if you want to conform to a particular string literal quotes, because this is JavaScript, you can use double quote, you can use single quotes. If someone comes from another programming language, C++ or Java, you might want to use double quotes, but your team says we use single quotes here. Which one is being used for YUI? Single quotes. So if you want to do in-place modification of all the quotes, then you have to get the syntax tree, walk through all the nodes and figure out which one is string literal. And if it has double quotes, you need to change it to single quotes. Sometimes you need to escape a couple of characters as well. Another wonderful thing is to have a transpiler. Eric mentioned this yesterday. If YUI adopts ES6 modules, then eventually you can write the modules according to the ECMAScript 6 syntax and then still gets translated into whatever. Here's a nice simple transpiler that does only one thing. In ECMAScript 6, we can have lexical block scope. Everyone is familiar with var, but it trips a lot of programmers because it has function level scope. Using let, you can see let j there. The scope for j is contained within the closest curly braces. In this code fragment, I have two j's, the outer and the inner, which I use inside the loop. So there are two completely different variables with ECMAScript 6. This allows you to get rid of crazy manual hoisting and worry about whether there's conflict or not. But the code only runs in future browser that supports ECMAScript 6 lexical block scope. How do we deal with today's browser? So there's a transpiler called devs.js that convert this code to something like this. So it knows that the inner j conflicts with the outer one, so it changed the name to j $0. Of course, it's also changed other occurrences of that variables. This is non-destructive because first, it doesn't really care about anything else besides let, and it doesn't even change your coding style. It doesn't remove comments. Basically, everything is oblivious to that transpiler. So if you worry that having a transpiler in your build setup will scramble your code somehow that you won't be able to understand it again, don't worry about it because there are non-destructive transpiler out there. So that's all I want to say about syntax transformation. Let's go into dynamic code analysis. Oftentimes, you need to implement certain algorithms. You have an address book application, and there's a new engineer or an intern, and then you give him the task of creating a sort function. After a while, you ask, how's the speed? And he said, fantastic, 10 contacts, 2 milliseconds, super fast. But it doesn't tell anything about the scalability of this implementation. So you go and review the code, and then you look at this code, and it looks like this. So your jaw drop, and after you collect whatever remaining from your jaws on the floor, you realize that, no, this doesn't work like this. So in a very complex application, it's too costly and sometimes prohibitive to implement a formal analysis of the runtime complexity. In this case, I made it really simple, so you can say, hey, this is, you can come up with some big O notation of this simple code, but it's very difficult for real-world code. What you can do is to inject special instrumentation so you can monitor the runtime complexity. Everyone knows that in a sorting algorithm implementation, the swap function is critical. It tells you the complexity of that sort implementation. So in this case, I can inject a log function, a log call that will collect the statistic of how many times this function is being invoked. You can do this using special tools. I mean, you can obviously instrument this manually, but it doesn't work like that. Let's do a demo. Here's that fantastic sorting implementation. And if I click run, then it's going to inject extra code not shown here, and then execute the sorting function, and it tells me if I mouse over, this is being called one time. We don't really care about that, but this one is very important because it's almost called it's called almost 5,000 times. I can change this to only 10, and then you can see this is now 45 times. So you can play with different input size and different execution tracing. With this, you can come up with this graph and then realize that that particular implementation is not necessarily linear. So talking about instrumentation, let's go to different topics. So there's a lot of test madness, TDD, BDD, and I theorize one day it's also PDD. One thing that is very important about tests is that do we test the right thing? This is the question that you should ask yourself. Are we just going with the hype, trying to get as many tests as possible, or do we really plan the test in such a way that it's meaningful? So I was talking about instrumenting the code, but can we instrument the test so that you get a meaningful metric out of it? So there's something called coverage. Istanbul is a fantastic tool. It was born here. How many of you here use Istanbul? Cool. The amazing thing about Istanbul is that it just works, and it also gives you the information about branch coverage. How many of you here track branch coverage? Hopefully that number increases next year. Here I give you a code snippet, 2 lines of code, very simple, but it has a bug. It's your homework to figure out the bug. And I have one unit test. So if I run that unit test and you only track statement coverage, it will look like this. So there's if statement, there's another statement, there's another statement, there are 3 statements there. If I run the test, all those statements are touched. But if you run it through Istanbul, then it tells you that that if statement has an else branch that is not being executed at all by your unit test. So the unit test tells you 100% statement coverage, 100% line coverage, but it misses one branch. And if you realize that it misses one branch, you either change your code in such a way that it doesn't have that branch, or you add more tests so that particular branch is also covered. And when you do that, you'll discover the bug in this function. So branch is very important. You don't want to get into the trap of not having the actual branch coverage. Just relying on unit test and statement coverage won't give you a lot. So you need to be very careful about branch coverage. And if you're crazy, there's an advanced coverage, advanced usage of Istanbul, where it can also validate the amount of coverage. How many of you here use these features? Nice. This example, check dash coverage, dash statement -5 means at most 5 statements can be uncovered. Dash branch -3 means at most 3 branches can be uncovered. And dash function 100 means 100%. It should touch all the function 100%. Your tests cannot leave one function uncovered. Now, if somehow I manage to introduce a branch that is not covered, that's how Istanbul is going to complain. It says uncover count for branches 4 exceeds the threshold 3. This allows you to catch unintentional mistake because someone creates a function or modify the code, and some part of the code is not being covered. So there's this wise man that once said that if you think Jaslyn hurts your feeling, wait until you use Istanbul. When I use Istanbul for the first time, it really breaks my heart into pieces. So lesson learned, if you haven't done code coverage analysis using Istanbul, when you do that for the first time, please play this song in the background, because this is the tunes that you can completely relate to. I mean, who doesn't like Wham? It's almost December, by the way. So it's, if you're an engineer, if you're developers and you don't do code coverage, I mean, my advice is, go home, take some rest, and think about the meaning of life and universe and everything. If you're a team lead or managers and you do not encourage or promote and enforce the use of code coverage tool, then you should also go home. Maybe it's the right time to spend more time with family and friends, because it's such an important tool. It makes it gives a meaningful metrics as you release one version to another. It gives confidence to your team and the customers that you just don't add features just for the fun of it. So some final words. All these tools, they are designed to make you more defensive. They prevent you from embarrassing yourself too much in the open. And there's also an important philosophy where you need to put multiple layers in many places. If you develop Yahoo Mail, it'll be very crazy once if the CI system tells you that, hey, I can't log in as soon as you change one code. So you want to have an immediate feedback. If you change one line of code, can you run a smoke test that tells you whether the basic stuff works or not? And you can do that by a lot of tools that I've just mentioned. Another thing that is very important is to make you, having less emotional attachment to your code. So imagine you create a pull request for YUI, and there's this Mr. Viewer tells you, my good man, your code is a piece of garbage. Maybe your reaction is like this. So, the worst thing that can happen is that you grow fears, and we know that fears leads to anger, and anger leads to hate, and hate leads to, exactly, suffering. So just like Yoda, we don't want you to fall into the dark side. So it's at one point, if you're a maintainer, you want to grow your community, but you don't want to offend people. And the symmetry works not only on that side, also on the right side. I've been called names just because I mentioned, hey, our contribution guidelines mandates that you do A, B, C, D, E until Z, and you're just doing A and B. And people tell me all kind of nasty things. So yeah, I used to tell my friends, if you want to practice self-restraint, no need to go to this expensive anger management course. Here's a free alternative: maintain an open source project. So being a maintainer is already hard, so you don't want to get into this flame wars with some very emotionally sensitive audience. But it's different if a machine tells you that, hey, Dave, you can't do that. Just because, for example, you create a function and you forgot to create a test, and that regresses function coverage or branch or statement or whatever. You just admit defeat. I mean, you can punch your MacBook. It doesn't give you anything. But then you just improve your code. This is, I believe, the pinnacle of modern JavaScript tooling. Less about how we pass the test, more about how do we increase our quality. And that's sort of like the final frontier version of our tools. The mission for the next 5 years is how can we build tools that boldly analyze what no man has analyzed before. And hopefully by doing that, we can keep writing amazing applications using the language that we all love. Thank you very much.
All right, we have time for some questions, so raise your hand. You know you want to. There we go.
So I was wondering if you could address or give some guidance for avoiding falling in the trap of code coverage. When you look at a code coverage report, it says 100% coverage, and yet you have still failures in the wild, or use cases. What are your tips for that?
It's usually very important to decouple code coverage and test failures. The basic usage of code coverage, as the name implies, is to track the coverage of the test. So what you should do is, regardless of how bad the coverage is, set a threshold, maybe 20%, and then make sure that any subsequent commits check in won't reduce that number. So that's orthogonal whether even if you have 100% coverage, some tests still fails. Is that your question?
It's more the difference between a merge conflict and a semantic conflict. Like something that you the coverage doesn't actually represent that you've tested a piece of data or like the flow of that. I'm just speaking from experience. I've had really well covered projects that at some point a bug comes up because a user put in different information, or it was a different time of day, or some silly thing like that. So
that's entirely possible, because even if you do brand coverage, it doesn't track all possible combination of the flow of the code. I mean, if you have 100% coverage and you still get some bugs, that's also good. In a way, in a good way.
All right, do we have any more? All right.
Code coverage is just one metric, so don't be too religious about it.
Hi, yeah, I have a question. We have this nice syntax tree that we can do. We can analyze our code. You mentioned like writing custom linters or presumably also custom transformations. In your experience, has it been difficult to write those? Are there tools to assist in finding patterns in your code? I guess I'm thinking of something like XPath, something like a tree pattern matching approach.
Some folks are working very hard to come up with some query language for AST. XPath is nice, but it's really, really hard to debug. My personal preference will be something that resembles CSS selector, but there's no concrete final work that we can use right now. If you use ESLint, which is a new linter from Nicholas Zakas, it has the ability to, it is plugin based, so you can write a small modules that you can inject into ESLint that checks, for example, I don't know, Boolean types. It comes with additional sugar on top of plain vanilla syntax tree, so you can look up whether there's comments attached to this and all kind of wonderful things, scope analysis. So I don't think my dream would be you can describe your code patterns that you want to avoid declaratively, but I don't think we're there yet. Maybe next year conference.
All right.